The Flex4RES project analyzes flexible Nordic and Baltic energy systems. This video presents results for Denmark. Before going into details, let's have a look at the key findings for Denmark. Continuing business as usual, but allowing for transmission investments in 2030 beyond the NSOE 10-year network development plans, results in a doubling of wind capacity and production. This leads to an increased electricity export from Denmark. By changing the current volumetric grid tariff and taxation scheme towards capacity-based tariffs, power to heat capacity is increased by 50%. This takes the share of power to heat to 34% of all district heat demand. Heat storage is expanded considerably up to 250 gigawatt hours in storage capacity, mostly represented by seasonal storages. This results in a Danish electricity supply share of 90 to 97% supplied by wind and solar. Now, let's have a look at the results in more detail. We start out in the electricity sector. As mentioned earlier, the impact of introducing transmission capacity leads to a doubling of wind capacity. The optimal combination is enhancing policies and allowing increased transmission capacity. This leads to the largest deployment of wind. Fossil fuel-based electricity will be phased out in all scenarios, while biomass-based CHP will remain. Solar PV is also deployed extensively in all scenarios, but due to the low capacity factor, it's not generating as much as wind. Increased transmission and the subsequent large wind capacity is also reflected in the electricity generation, where generation is also doubled. A shift from solid biomass to biogas is seen in all scenarios over the years. Now let's look at the heating sector. Heat generation capacity is reduced in all scenarios due to increased efficiency, for instance through heat pumps. Deployment of solar heating is also considerable, especially in the business as usual and connect scenarios, where volumetric taxes and tariffs act as barriers for power to heat. Installed capacity of biomass boilers is reduced with the new tax and tariff scheme in the policy and combi scenarios. Finally, it's worth noticing the impact of shifting taxes and tariffs in the policy scenario, whereby power to heat is increased considerably. While waste continues to make up a significant share of heat supply, power to heat increases in the policy and combi scenarios due to the shifting of tariffs and taxes. Solar heating substitutes power to heat in the business as usual and connect scenarios. And co-use is phased out already by 2030 in all scenarios. While there is a general shift from biomass to biogas, use of biofuels is generally reduced with time. And finally, let's look at storages. As mentioned in the beginning, the deployment of heat storages is considerable. Already from 2030, we see a large deployment of especially seasonal storages. There is a synergy between heat pumps and storages, where operation of heat pumps is almost continuous, filling up the storages throughout the year. This same effect is seen for solar heating during the summer season. Without transmission, flexibility will be provided by heat storages as seen in the business as usual and policy scenarios. You can find similar videos with country profiles and recommendations the same place you found this one. For even more details, have a look at flex4res.org.